Time feels simple on Earth. Seconds, minutes, and hours flow in a steady rhythm. But the universe plays by deeper rules. The moment we leave Earth, time begins to stretch and shift. And on Mars, time does not move the same way it does here. Today, we will answer one question. If it is exactly 12 o'clock midnight on Earth, what time is it right now on Mars? Earth measures time by rotation. One full spin takes 24 hours. But very slowly, Earth's rotation is changing. Our days are getting longer, tiny fractions at a time. To keep time precisely, we use atomic clocks, the most accurate clocks humanity has ever built. Yet, even atomic clocks are affected by motion and gravity. Time itself bends depending on where you are and how fast you are moving. Einstein's theory of relativity tells us that motion changes the flow of time. This is described by this equation. It says, time equals the stationary time divided by 1 minus the velocity squared divided by the speed of light squared. But Earth and Mars move far slower than the speed of light, so this effect is tiny, only millionths of a second. The real difference between Earth and Mars comes from something much simpler: the length of their days. A day on Mars, called a sol, lasts 24 hours, 39 minutes, and 35 seconds. That is almost 40 minutes longer than an Earth day. Mars also moves more slowly around the Sun and has weaker gravity, but these effects are small. The important part is this: every sol on Mars ends 40 minutes later than it would on Earth. And over time, that small difference grows larger. Imagine two identical clocks, one on Earth, one on Mars, perfectly synchronized at the same instant. After one Earth day, the Mars clock is already behind by almost 40 minutes. After a week, it is nearly 5 hours behind. After a month, more than a full day. This is how Mars slowly drifts away from Earth's sense of time. Now we can finally calculate what the local time on Mars would be when it is exactly 12 o'clock midnight on Earth. To do that, we look at the difference between the length of a Martian sol and the length of an Earth day. A Martian sol lasts 24 hours, 39 minutes, and 35 seconds. An Earth day lasts exactly 24 hours. When we subtract these two values, we get the daily time difference, which we call delta T. Delta T simply means the change in time, or how much Mars falls behind Earth every day. Here is the equation spoken in words. Delta T equals the length of the Mars day minus the length of the Earth day. Using the real numbers, delta T comes out to 39 minutes and 35 seconds. This means Mars rotates more slowly than Earth, and its local time drifts behind a little more each day. Now that we know delta T, we can compute the local Martian time when Earth reaches midnight. The equation is simple. Mars local time equals Earth time minus delta T. So if Earth shows 12 o'clock midnight, we subtract 39 minutes and 35 seconds, equals 11:20 and 25 seconds. That means at the exact moment Earth crosses into a new day, Mars is still living in the previous day, at roughly 11:20 and 25 seconds at night. A different world, moving through a different moment in time. As we prepare for humans to walk on Mars, we must learn to live with a new clock, a Martian clock. Time is not universal. It bends, it shifts, and it changes from world to world. And someday, when people live on Mars, their midnight will not be our midnight. Their time will belong to their world. Thank you for joining this journey through Earth, Mars, and the strange, beautiful nature of time. Subscribe for more amazing facts.